In this lesson, we are going to complete the square. This is a method of solving quadratic equations, and we will start by completing the square when a is equal to 1, the leading coefficient. And also we will practice writing the vertex form of a quadratic equation by completing the square. Here are rules for completing the square. First, we need to remember the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. We will write the equation so that the c has been moved to the right side of the equal sign. We want to make sure that the leading coefficient is 1, and then we'll take the b, the middle term, divided by 2 and square it and add it to both sides of the equation. We'll write the perfect square, and then we'll solve the equation by taking the square root of both sides and finish simplifying. So the first thing we want to do is to remind ourselves how to find a perfect square trinomial. So we have an example of x squared minus 8x plus something. So what we're going to do is say to ourselves, what number would make that a perfect square? Here's what we do. We take the b, the negative 8, we divide it by 2, which would be negative 4, and then we square it. Negative 4 squared is 16. This creates our perfect square trinomial, and when we factor it, remember we take the square root of x squared, which is x, the square root is 16, which is 4, and we use the middle sign, and that would be the factoring of our perfect square trinomial to write it as the square of a binomial. So let's use that process for solving a quadratic equation by completing the square. Step 1. Add the c to both sides to move it. Step 2, if you rewrite the quadratic with a blank where you're going to put in the other part of the perfect square, and remembering to write the blank on the right side as well because you need to add the same quantity to both sides. Step 3 is to take the b, the 6, divide it by 2, which is 3, and then square it. That's what we're going to add to both sides to complete our perfect square trinomial, and then we'll add it to the right side as well. Step 4 is to factor. Remember, when we're factoring, we take the square root of x squared, the square root of 9, and using the sign of the middle term. And we will combine like terms on the right side. Then we solve by doing the inverse operation, which is to take the square root of both sides. The square root and the square cancel each other, so we have x plus 3 is equal to, remember that it's going to be plus or minus the square root of 17. And then we finish simplifying by subtracting 3 from both sides. And when we write our final answer, we'll write the negative 3 first, and then put the plus or minus square root of 17. Let's try another example. So we have our x squared plus 12x plus 3 is equal to 0. So first we'll subtract 3 from both sides, and we will rewrite our quadratic with the blank to remind us to finish completing the perfect square trinomial, and the blank on the right side reminds us we have to add that same quantity to both sides. So we'll take our b, which is 12, divide it by 2, which is 6, and square it, which would be 36, and that's what we're going to add to both sides. Then we're going to factor to find our square binomial. The square root of x squared is x, and the square root of 36 is 6, and the sign of the middle term is positive, and we will combine like terms on the right side. We continue solving by taking the square root of both sides, remembering that a square and a square root cancel each other. So we will have x plus 6 is equal to plus or minus the square root of 33. 33, if we did a factor tree to simplify, would be 3 and 11. So that can't be simplified any further, so we'll subtract 6 from both sides. And so to finish, we have x is equal to negative 6 plus or minus the square root of 33. Let's try another one. Let's add 4 to both sides. So we have x squared minus 3x plus blank equals 4 plus blank. Now we're going to take our b and we're going to divide it by 2. So negative 3 divided by 2 would be negative 1.5, but I suggest that you leave it as a fraction, an improper fraction, and you'll see in just a moment why. So we have negative 3 over 2, and when we square that, we get 9 over 4. And we're going to add 9 over 4 to both sides. When we factor, we take the square root of x squared, which is x, and the square root of 9 over 4, when we take the square root of the numerator and then the denominator, we have 3 over 2, and our sign of our middle number is minus. Now what we'll do is we'll make 4 an improper fraction. That would be 16 over 4, and when we add 16 over 4 and 9 over 4 together, our sum would be 25 over 4. I hope you can see as you're looking ahead that now when we take the square root of both sides and we've left these as improper fractions, that we can easily take the square root. The square and the square root cancel each other, so we have x minus 3 over 2, and that equals plus or minus the square root of 25 over 4. The square root of 25 is 5, and the square root of 4 is 2. So we're going to add 3 over 2 to both sides. So we have x equals 3 over 2 plus or minus 5 over 2. In this case, we need to finish simplifying because we don't have any roots left, and we will have number values. So 3 over 2 plus 5 over 2 is 8 over 2, which equals 4. And then we have 3 over 2 minus 5 over 2, which gives me a negative 2 over 2, which equals negative 1. So please be sure if you have a result where you don't have a root left that you finish solving both the plus and the minus to come up with your real number solutions. Next, we want to write this quadratic function in vertex form. Remember, our vertex form is y equals a, the leading coefficient, times x minus h, the quantity squared, plus k. We can do this by completing the square. So we're going to set our original quadratic function equal to 0, and we'll use the completing the square method to find our vertex form. First, we're going to subtract 16 from both sides to move the c to the other side and rewrite our quadratic function using a blank to complete our perfect square trinomial. Take the b and divide it by 2, which would be 3, and 3 squared then is 9. We'll add 9 to both sides. Okay, when we do that, we're going to factor, writing our perfect square binomial, x plus 3, and we're going to simplify on the other side, which is negative 7. Now if you take a look at the vertex form, you're going to notice that it looks really close to what we have so far. But we need this to equal y, so we're actually going to add 7 to both sides. So we have x plus 3, the quantity squared, plus 7 equals 0. Now we just replace the 0 with the y, and we have our quadratic function in vertex form. And it asks us what the vertex is, and the vertex is going to be at negative 3, positive 7. So that's one way that we can write our quadratic function in vertex form. There is the other way, which is to simply find the vertex of a standard form of an equation, which this is the standard form, by using the formula negative b over 2a. So when we do that, we take the negative 6 and we divide that by 2 times 1, which is 2, and we get our x value of negative 3. Then we're going to substitute the negative 3 into the equation to find y. So we have negative 3, the quantity squared, plus 6 times negative 3, plus 16. So we have 9 minus 18, which is negative 9, plus 16, and that gives us the answer of 7. So our vertex is the point negative 3, 7. So we can write the vertex form by putting in the vertex, and we look at the original standard form and find our leading coefficient. Our leading coefficient is 1, so then we write it as x plus 3, the quantity squared, plus 7. So we can use either method. Let's try another example. We're going to set this equal to 0, and we'll start with completing the square method, to finding the vertex form. So we're going to subtract 5 from both sides. We'll rewrite the quadratic function with a blank so that we may complete the square and find the perfect square trinomial. We'll take the b, which is 8, divided by 2, which is 4, and so we will add 16 to both sides. We'll factor the perfect square trinomial by creating the binomial that we will square. So the square root of x squared is x, and the square root of 16 is 4. Plus sign because the middle term is positive, and we will combine like terms, which gives us 11. Then we simply subtract 11 from both sides, and we would set it equal to 0, but we'll replace the 0 with y. So we have x plus 4, the quantity squared, minus 11, and that's our vertex form. So our vertex of this particular quadratic function is going to be at negative 4, negative 11. If you would prefer, you may use the formula negative b over 2a to find the x portion of the vertex. So that's going to be negative 8 over 2 times 1, which gives us negative 4. And then to find the y value, we simply replace our x, doing substitution. Negative 4, the quantity squared, plus 8 times negative 4, plus 5. So y is equal to 16 minus 32, which is negative 16, plus 5. That gives us y is equal to negative 11. So our vertex is at negative 4, negative 11. And when we write our vertex form, we take a look at our original standard form and see that the leading coefficient is 1. So we don't need to write that. And we'll put x plus 4, the quantity squared, minus 11. Either method will work. You just need to decide which one you would like best to do. So let's review. When you're completing the square, make sure that you have the equation in standard form, and then move the c to the right side of the equal sign. Make sure that your leading coefficient is 1. Then take the b, divide it by 2, and square it to add to both sides of the equation. Factor by writing the perfect square binomial, and then solve by taking the square root of both sides and finish simplifying. Please make sure to complete the reflection.